Good morning, good afternoon. Welcome to the Mexico Now webinar on Industry 4.0. I appreciate everyone's time here. Our topic today is Industry 4.0. Is Mexico up for the challenge? My name is Mo Abu Ali. I'm with IoTco, and it's a pleasure to be here today. I'm also very pleased, actually, to have three of my esteemed colleagues here. Dr. Ramiro Villeda is on, Mr. Eric Palencia, and Mr. Javier Acosta. And I would first appreciate if they can start introducing themselves. Gentlemen, welcome to the webinar, and looking forward to have a great conversation as always. If I may please ask Dr. Villeda, if you can introduce yourself, that would be a great start.
More just my personal or my company?
Just personal, who are you?
Oh, okay. I have been doing my manufacturing since 1976. I have been engaged in many projects in the automotive industry, and I look forward to this coming year, where many companies are going through very difficult times, but they are also aiming to move to a higher dimension. Thank you,
Thank
Mo.
you, Dr. Villeda, for being with us. And Eric Palencia.
Hello, Mo. It's a pleasure to be with you and all the colleagues. I'm Eric Palencia. I'm a founder of Intel Automation. I've been working in automation for more than 20 years. So we have been involved in different processes and industries like the automotive, and we are ready to share our experience with our customers. Thank you.
Thank you so much for being with us, Eric. And my good friend, Mr. Javier Acosta, how are you today? Are you muted, Javier?
Yes, I'm sorry. Thank you, Dr. Mo. My name is Javier Acosta, and I'm the CEO of Mechatronics. I'm the founder of Mechatronics, and we work a lot with Industry 4.0, giving to our customer value through data, through automation services, and integration too. So thanks for letting me.
Thank you so much. Thank you so much for being with us. So, to everyone who is joining us today, each of us is going to give a short presentation, starting with me and then the team. And then we're going to go and have a Q&A session with the team on the call today. At any time, please use the Q&A or chat and write questions that we will address during this hour. This will be an exciting hour. So let me start with my part. I'd like to kind of introduce the concept of the meeting, and then the team members can start showing their part. Let's start. So IoTco, Internet of Things company, we are a global organization that focuses on Industry 4.0. We have many great clients also with plants in Mexico, including Shiloh Industries and Maxion Wheels and Bocar. We focus on discrete manufacturing, including automotive and the industrial sector. And we provide a turnkey solution around predictive analytics using industrial AI and machine learning, as well as an academy for consulting and training, and MES and OEE and connectivity, basically Internet of Things strategy and products for the industry. IoT is a big field, okay, and it is not a new field. It's maybe a new naming, but we've been monitoring things for decades, actually. When you fly in an airplane, you're being monitored. The jet engines are being monitored. Before you arrive at an airport, they know if you need to fix the bearing on the jet engine, for example. So safety critical industries like power generation and aerospace. But more and more, Industry 4.0, the fourth industrial revolution, was formed to support manufacturing, to support us to go away from having siloed data. You will always see that you have machines, you might be collecting data, you might have a manufacturing execution system. Most probably you have an ERP business system, but in many cases they are fragmented. They are not connected to each other. You have the information technology layer and the operational technology layer are not converged, right? So the fourth industrial revolution is about converging your information technology and operational technology. And it's important to always have this strategy in mind. What is your ROI? What is your why? What are you trying to achieve? What's your business case? And how do you get connected? How do you capture real-time data from the factory floor? How do you do analytics? How can you measure your performance in real time? How can you start predicting performance in the future? And then what is the technology that makes sense for your organization? How can you start now, and how can you scale the infrastructure and all the architecture required to realize Industry 4.0? And the business case actually can cover any manufacturer, whether inside the factory or whether on the products that you're producing, right? You are sensorizing machines, you are sensorizing parts, you want to improve your overall equipment effectiveness, you want to improve uptime, you want to optimize your preventive maintenance schedule, you want to have better customer satisfaction and better users that continue using your products, right? So metrics are key, and we're going to talk about the role of getting connected and the role of having metrics on your factory floor. And hey, just think, are you measuring OEE today in real time? Are you measuring the health of your machine? Are you measuring when the machine is going to fail before it fails? Are you diagnosing why is it going to fail, right? Industry 4.0 can help you achieve this, okay? So the goal of this webinar and the conversation I'm going to have with the team today is how can we transition you from an Industry 3.0 to an Industry 4.0 strategy? And if you're already in Industry 4.0, how can you improve your journey even further to achieve results and to achieve a business case for your operation? So with this short introduction, I'd love the attendees to give their introduction and how they see Industry 4.0, and then we will have a Q&A session. Dr. Vieta, I would love for you to start, please.
Thank you, Mo. Thank you. In 1989, we helped an organization to move into what is known as just-in-time manufacturing, or TPS. Since that time, we have been helping companies change and evolve. In 2009 and 10, we helped several companies overcome the financial crisis of 2008. And now we are facing again another new normal. And over these 30 years of experience, we have found that when you have new technology with old rules, we are set for a very unpleasant experience, which means lots of lost time and money. So the way we see it is that knowledge evolves, and 40, 50 years ago, we had lots of inventory in our factories. In the late 70s and 80s and 90s, we did a tremendous job to reduce inventory. But now we have taken inventory reduction to an extreme. We have to understand that inventory, the same as machines, are an asset. You cannot have too many or too little, because inventory is, if a particular working process, is a store capacity and capture money. And if you have the right inventory in the right position, which we call the strategic inventory, it helps you improve your market service level. Here the point is that we have taken the idea of inventory reduction to an extreme, and that is affecting us. Industry 4.0 technologies such as sensors, artificial intelligence, and machine learning allow us to track and improve equipment utilization, which is good. But also for many companies, we have found that a better use of those technologies is to improve the flow of information and material in the supply chain. That will be my topic during this conversation. In a new world, we believe that we need new technology. I mean, in a new world, we need technology. We need new rules and new thinking. Basically, we need to focus on flow. And let me use one definition of flow: is the rate at which a system converts material to product required by a customer. It's a very simple equation here. If we increase visibility in our factories, we'll reduce variability. If we reduce variability, we improve flow. If we improve flow, we improve cash velocity, which allow us to make more money with the same investment, allowing us to increase the return on investment.
Dr. Vieira, thank you so much for your introduction. Looking forward to conversate with you about Industry 4.0. Eric Palencia, how about yourself?
Okay. At Integral Automation, we focus mainly in developing complete solutions for our customers. That means right now we are able to design a concept based on the product requirement or the production requirement of our customer. We are able to manufacture the parts. Even we have some partners and suppliers that complement our capabilities, because sometimes the demand is greater than we can manage, but we have this network of partners to provide the services to our customers. We're able to assemble all the components, to design and wire all the electronics and the electric controls. We're able to code and test all the software required for the different systems, the PLC, the drives, the vision systems, robotics, and so on. And we're able to deliver and mainly to connect these machines or existing machines to the Industry 4.0 or either to some legacy systems or databases or ERP systems. We manage this with the involving different disciplines like robotics, control, automation, process and mechanical teams, information technology, and the management of the people to achieve the project success. One of the major challenges for us is to connect different manufacturers that currently are installed at the customer site. And this is one of the reasons why now Industry 4.0 is being a very important thing, because right now it's possible to connect very different brands, different manufacturers into a complete solution. In the past, it was not as easy as it could be right now. So we provide services from consultancy, project, electrical design, mechanical, installation, programming, and the management of the project, and the service after sales once we have installed the solution. We have been working very different industries and processes that are involved in the automotive industry, for example. We have been working with car manufacturers, and we have worked with partner manufacturers as well. So we have been developing different kinds of solutions, including the Industry 4.0 solutions and IT solutions. We have 3 business units. Integra Technology focus on the projects. Integra Supply, we provide components. We represent some brands. We provide training for PLCs and robotics and so on for the training of the people of our customers. We are located in different cities. Our main office is here in San Luis Potosí, but we provide solutions to customers in all the country and other countries like in the USA or in Latin America. We have 20 years and we are a 100% Mexican company. That's my side. Thank you.
Thank you so much, Eric Palencia. Thank you for being with us. And Javier Acosta, your introduction, please.
Thank you, Dr. Mo. Thank you, everyone. I will share my screen. Thank you all, everyone, for your time, for letting us to share with you some of our experiences in the field of Industry 4.0. And those who haven't heard of our company, we are Mechatronics. Our slogan is Intelligence 4.0, more than automation. And we work a lot with different core technologies, intelligent automation, machine vision, robotic platforms, Industry 4.0, and artificial intelligence on the applications industries. Our trajectory, we born on 2000. We are certified on ISO 9001, 2015. We have 14 years with this certification. We have more than 3,000 solutions on the industry, and we have an R&D lab focused just working with new products on Industry 4.0. We have different engineers, master degree and PhD working on products focused on Industry 4.0. And our footprint, it's on USA and in Mexico. We offer services for 5 countries, USA, Mexico, Brazil, Italy, and China. And this year we work a lot for Canada too. Our focus is on Industry 4.0, how we can connect from the customer to our supplier, and then from the supplier to our company, and how we need to be this connection to collect all this data, all this information. We are more hands-on. We are not work on the consulting industry. We are more hands-on the field, and we install systems to do this connection and this whole integration of our systems to be connected. If we disconnect all this system, we want to lose a lot of information. So we are focused on all this connection. We work on the field of intelligent automation, and when I talk about intelligent, we collect a lot of data, and with this data and with the data sets, we create intelligence in all the machines that we can create. And in this video, I want to share with you some of our experiences. These machines that we build to our customer, it's focused in a specific application. So we create all this machine. We work a lot with robotic applications, with cobots, with machinery that we can empower the production of our customers. And also this production, and all this data is connected to the cloud of our customer using different platforms for the medical industry, for electronic industry, for automotive industry. And we are happy to share with you all these experiences. We work a lot with artificial intelligence to empower our customer to their assets, their production, their people. And we digitalize all this information to create value. All these companies, they trust us, and we are working with these companies for around 20 years. And thank you, Dr. Mo.
Yeah, thank you so much, Javier. And I really appreciate all our guests today. Just a reminder for all the participants, if you have any questions, please start writing them in the Q&A, and we will address them. And I will just invite my panelists to switch off their videos. We have a quick message from our organizer. Thank you. Welcome back. We would like to start the Q&A session with my guests, and I appreciate if the guests come back online. Again, our topic is Industry 4.0, but my first question is actually going a bit into the history. To understand Industry 4.0, we need to first understand Industry 1.0 and Industry 2.0. And therefore, Dr. Vieda, a first question to you. How did Mr. Henry Ford's innovations allow the world to migrate from 1.0 to 2.0? That would be a great start.
Thank you, Mo. Okay, here the idea is to understand and learn from Henry Ford's experience to evolve the industry from 1.0 to 2.0. Um, Industry 1.0 was based on several discoveries. One of the most important ones was the body of knowledge developed by Frederick Taylor, which was focused on improving and standardizing manufacturing operations one by one or at the micro level. Henry Ford took some of those ideas, but really his contribution was how to improve a system to produce a complex product massively. In other words, he found out, and this is very important because much later, Dr. Goldratt took some of these ideas and Dr. Goldratt created the theory of constraints. But it was Henry Ford who found that in a system, the slowest task governs flow. And that if we're able to synchronize the activities to, through, and from those slow tasks, we will achieve or we will increase the production of the system. In other words, Ford's innovations on Frederick Taylor's, he went above the work on individual stations. Henry Ford focused on how to improve the whole system. In other words, Henry Ford did not improve his machine shops or job shops. He was looking at the system, and his aim was to improve flow. Let me ask you a question here. Here we have a system. Let me ask you this question. Does it make sense to improve every link, every operation? The answer is no. It doesn't make sense. Focus where your capacity or your reliability is not up to a pair, is up to the other links. I think we're making a mistake sometimes when we try to improve everything. It's not necessary. Let me come back again to the ideas of Chad and Deborah Smith. Before I explained that if we increase visibility, variability goes down, flow goes up, cash inventory goes up, and therefore return on investment. Visibility is defined as relevant information for decision making. Unfortunately, today, in today's environment where we're dealing with complex global supply networks, having relevant information is not easy or it's not simple. That's why Mr. Smith and Ms. Smith mentioned that we are fooling ourselves with irrelevant information. To summarize, Henry Ford's contribution is that he found that if we focus on this lowest task governing flow and the overall flow of parts to have them in the right quantity to keep the assembly line flowing efficiently, we will be much better off focusing on that system efficiency to obtain a high system efficiency than to maximize individual operations. Thank you, Mo.
That's actually that's great history, Dr. Veda. Thank you. And so that brings me to a question, maybe to Eric Palencia. So Eric, if I follow Henry Ford and I am now Industry 2.0, Industry 3.0, and I want to go to 4.0, a lot of people are thinking it's only for big companies. Okay, Fortune 500, Fortune 1000. So if I'm a small, medium-sized manufacturer, what's your advice to me to implement Industry 4.0 solutions?
Well, Mo, we have had the pleasure to work with the big companies, the car manufacturers, for example, that have the very big infrastructure and the up-to-date and the lead technology in their processes. However, there are a lot of car manufacturers even that have old machines and part manufacturers that have simple machines with very low technology. But fortunately for now, there are a lot of solutions that we can implement. In the past, we have developed custom-made solutions that required to have a very big investment in ERPs, in databases and servers and so on. Fortunately, today we have some solutions that we can implement. For example, we have partnership with Siemens, and they have developed this solution called MindSphere that allows the companies to connect and monitor their systems in order to proceed with the analysis or predict using the information that have been collected, and then digitalize and transform. And one of the advantages are from one sensor in one machine, in one line, inside a site of the customer. And it could be growing, and we can add more sensors, more systems, more machines, more factories, even more sites to monitor all that is happening in the process. So that means that this kind of solution is not just for the big companies, but even for the small ones, or even for the customers that have a lot of machines, but with few of them instrumented and with sensors and able to connect to the cloud. So in this way, we can start from the floor just with sensors, have some PLCs or some kind of controls, or maybe some have some systems, ERP or databases. But this solution allows the companies start from the floor right away. So these solutions right now is democratized and available for everyone. Thank you.
No, thank you for your insights. It's good to hear that both large and small and medium manufacturers of any size can adopt Industry 4.0, which maybe takes me to the current situation happening today. Javier, with the unfortunate pandemic, and hopefully everyone's healthy and everything, but this has affected companies' appetite and thinking about Industry 4.0. So how do you see the correlation between COVID-19 affecting Industry 4.0 and innovation, especially in Mexico?
Yes, Dr. Mo. So unfortunately, we have this problem, and it's affecting all the industry. The COVID-19 pandemic has created both public health crisis and economic crisis in the US and in a lot of countries too, like in Mexico. The pandemic has disrupted lives, pushes to the hospital systems to has most capacity, and create a lot of global economy shutdown. So it's affecting in our time deliveries, it is affecting in our production line, and also it's hitting our greatest value, our people. Our industry is facing the greatest challenge in the industrial history, but also it creates a lot of opportunities to a lot of implementations. And Dr. Mo, you start asking about how we can jump this in the industry 3.0 to the industry 4.0, how we can jump to 3 to the 4.0. So we need to include this new flexible problem that is the COVID. So I think so. This is on the implementation. We need to have a flexible implementation, allow us first to take care about those our most valuable asset or people, and implementing technologies to take care of them. That's so we need to include on all the formulas that we implemented from the industry and all the processes. We need to take care about our most valuable asset or people. So we need to start to digitalize our behavior and digitalize a lot of opportunities to take care directly to them. Thank you, Dr. Mo.
I really appreciate your feedback. Yeah, I think really the COVID situation is accelerating digital transformation, and people are now adopting technology to support the crisis. Thank you, Javier. So Dr. Vieira, to you, obviously you are very experienced with continuous improvement, which is a key for Industry 4.0. But if Industry 4.0 would help us transform ourselves to achieve just one objective, right? What should this objective be? What's one objective that I should keep in mind with Industry 4.0?
One lesson, one important thing to remember is we have been doing continuous improvement with very good results. What I will add here and I explain is now we have to think of continuous system improvement. I think in the past we have been optimizing or improving little parts of the whole. That is not very effective. Let me give an example. Right here, I'm sorry. Okay, let me go here. Here, what you have in between the black lines is the actual demand for a particular product at the Walmart region in the United States. The areas is shown by the between the two black lines. The blue lines show the distribution system variability to supply those Walmart stores in one city. So once again, the black lines show actual demand for a particular product for Walmart in one US city. The blue area shows the replenishment of those parts to those Walmart stores. And now the area in orange is the variability suffered by the factories or factory supplying those parts. Let me go back to the okay, here you can see. In other words, the actual demand, the actual variability of demand is not big. You can see it by the size of the areas shown by the black lines. But take a look at the orange lines. That's the factory response. What's happening here is a phenomenon known as the bullwhip. So the question here is, should we try to optimize or improve the orange line? Should we try to use technology to be able to follow those big jumps? Or should we do something to stop the bullwhip effect coming from the market, which is the black lines, into the distribution center and then into our factory? Now, think about this. If this is our factory, the orange lines, imagine the factories of our suppliers. So here the point is that if we think in a systemic perspective, the best thing we can do is stop the variability at the source. I will show a video to explain that. So here we have another explanation. Companies are facing several types of variability. On my right, in green, demand variability from the market. On my left, in black, supply variability, the variability produced by our suppliers. Those two are external. However, internally, we have also variability. The squiggly lines, the squiggly blue lines coming down are the variability for processes, which happen. Machine breaks down, the parts are not standard, the workers are not properly trained. However, the biggest internal variability is the management variability, is what we do as managers. Dr. Deming used to say that operational variability or the blue lines, that's Murphy's. That's what happens. It's very hard to control that. The big opportunity is with the management variability. And that was Dr. Deming always said, you should focus with that variability first. Only when the special cause or this management variability is addressed, we can successfully address the other variabilities. Many companies are planning or using Industry 4.0 technologies to reduce operational variability. We believe that that's not the best place to start. We advise our clients to rather focus their Industry 4.0 initiatives, particularly artificial intelligence and machine learning, to understand, quantify, and mitigate managing variability. Let me show you a video that explains this idea.
A perfect supply chain is like a river. But instead of flowing due to gravity, every piece moves non-stop in line with demand. But in the vast majority of companies, materials are only moving for 5% of their total end-to-end lead time. One reason is that we often have to make items in batches, so each piece is mostly either waiting for the rest of the batch to catch up, or waiting to be processed or sold. Another reason is that processing machines sometimes break down, or there are quality issues. Materials arriving unevenly at warehouses, or processing machines and interruptions to processing is what we call variability. Today, lean techniques have usually got these sources of variability under control. But the vast majority of supply chains still suffer significant variability by being driven by inaccurate forecasts through master production schedules. So materials move at the wrong rate, we get unbalanced stocks, and planners have to expedite by interrupting the schedules to prevent back orders. This leads to wasted capacity, volatile lead times, and the need for yet more stock and catch-up capacity to achieve good service. The solution is demand-driven MRP. It delivers flow by eliminating the expediting and variability that is caused by this use of inaccurate forecasts. Demand-driven MRP uses a small number of decoupled inventory positions within the supply chain. Each is sized and maintained according to the average rate of demand over the replenishment cycle and local lead time, plus a quantity calculated for error. And each is replenished following its own optimal cycle and sequence in line with demand, not the forecast. In this way, the entire supply chain responds autonomously to actual demand and can handle whatever is the normal level of demand variability. Planners say goodbye to expediting and concentrate upon planning and event management instead. Trial demand-driven MRP now and benefit from its transformational performance improvements. Contact Camelot's experts today.
Okay, here let me make a couple of comments. One of the reasons for the bullwhip effect is that we use forecast. Demand-driven MRP does not use forecast for operational decisions. In other words, companies who are using demand-driven MRP do not rely on a forecast to issue purchase orders or manufacturing orders. That's a huge, huge change. That's a game changer. So companies who are using DDMRP, this is kind of sad. The first company who implemented DDMRP was in the United States in 1998. This body of knowledge is over 20 years old. Companies who are using DDMRP can expect at least a 40% reduction in inventory in the whole system, in the whole supply chain. Big reductions in lead time. And here I have a very good news. Next year, in North America, more than 50 manufacturing companies, mostly in the automotive industry, will move into DDMRP. This is a game changer. Thank you, Mo.
It's a very interesting perspective, yeah, Dr. Ramiro, regarding thinking about management variability when you open a key for Industry 4.0. That's actually a very interesting view. If we take that view, Eric, if I pass it to you and you take us on a high level, maybe 35,000 foot level, what does an implementation structure or phases look like for Industry 4.0? What would you suggest?
Well, I think based on our experience that the first is to identify where as a company we are located in this process. That means that very important to assess what's happening in our company. So according with this partnership we are doing with Siemens, there are several steps that are required to implement in order to achieve the goal of the Industry 4.0. So it's important to identify in which of these steps we are located, because sometimes we want to perform machine learning analytics, but unfortunately we have no sensors at the floor. So it sounds very strange at this moment, but I can say for sure that there are a lot of companies, even the big ones, that sometimes have not enough sensors at the floor. So it's important to monitor everything that you require to analyze in the future. So there are several steps that we need to implement, and for that we have several steps that we are partnership to identify the customer digital maturity level. And then we implement a conceptual architecture and a technical consultancy. Then we verified the inventory of the assets the customer have. For example, what kind of PLCs, which brand, which models, are they able to connect or to communicate with other systems, which kind of protocols. We need to identify the most important KPIs, and then it's important to connect everything to a gateway that is the main component for the system, so we can bring different systems and machines together to connect and send the data into the cloud. Then we are able to implement different solutions, for example, for management of the energy, or to implement OEE, and then we can provide different dashboards to the different stakeholders of the systems for their operation, and we can provide annual maintenance policies to the customers. And I think that's the steps we need to follow to implement the system.
That's actually very systematic, and it starts with assessing the digital maturity. I think that's very wise. Thank you for sharing that, Eric. Javier, I'm going to come back to you always with the relevant current state conditions. So now that I know how to implement Industry 4.0, how do you think the current COVID-19 situation is shaping this implementation, whether it's positive, whether it's negative? How do you feel is the impact on the implementation?
Okay, thank you, Dr. Mo. How the COVID is reshaping the implementation for Industry 4.0. Technologies 4.0 more frequently be used to monitoring their processes, their production through different methods and different platforms too, tracking the flow, tracking the production, tracking the quality through different sensors, different platforms, different techniques. But in the COVID area and the post-COVID area, not just the COVID area, the post-COVID area too, we need to digitalize not just the machine, and we need to include digitalize our staff using face recognition, measuring the body temperature, and so we need to digitalize our sanitization. This is a new concept that we need to include on the Industry 4.0, digitalize our sanitizations in order to avoid infections on our production lines. Let me share with you some example. I'm gonna share my screen. Here, we need, in this example video, we are using this technology that we create, that it's traceability. And this traceability, it has a camera and it has sensors to detect the body temperature. This technology are used on machines on the production lines to detecting on real-time temperature. And we are detecting with RFID here in the machine, the ID of our staff. So we catch and we have this union between the ID and the temperature recognition. Also, we have a camera to are detecting on real time their emotions. And also, if they have their face cap, put it on the right place. So this is an example of how we can detect in the body temperature and also the machine metrics. Here we have our product that is called traceability. We have here a normal production that we detect the RFID and we detect the body temperature, and also the machine start to working. So in order to avoid infections, it's very important to have all these implementations to digitalize our staff. So it's very important to us detecting the mass detection, the body temperature, and also the emotions of our employees. If we include all this stuff, so we are reshaping the way that normally the people are using the technologies 4.0. And remember, we need to take care about our most valuable asset or people. Thank you, Dr. Mo.
Absolutely. Thank you so much, Javier, for sharing this. I'd like to give a final question to each of the members here, and just be aware we only have a few minutes left, so let's keep it short. Dr. Vieda, how is Toyota implementing Industry 4.0 today?
Thank you. Let me use a presentation given by a Toyota Vice President North America. This event happened at the end of October this year. The gentleman's name is Kevin Purdy. He is Vice President Toyota North America. And I will share a couple of slides from this presentation. But before we have to understand where Toyota is coming from. Toyota has been working on its famous Toyota production system since 1935. After the war, they were able to to achieve a very good flow in the factories using the TPS techniques. The second period, from 1956 to 1965, they developed internal pull systems to pull materials from, let's say, from the assembly plants to pull engine and transmissions, and the engine and transmission factories pull parts from their own operations. From 1966 to 1975, Toyota was able to create a full, complete pull system, which means if a customer bought a Toyota in Tokyo, that information was sent to a distribution center, that was sent to the factories, that signal traveled from the final customer all the way to their suppliers. So what you have right here is that Toyota developed something like DTMRP from 1946 to 1975. So Toyota is building on a very strong information system. From 1976 and on, they began to do Industry 4.0. So the point is, Toyota is maybe the most mature company to introduce Industry 4.0. And you will be surprised to hear that they're struggling. They are struggling to implement Industry 4.0. Okay, but to remember, factories are part of a bigger system. Here we have a tier 2 manufacturing facility, which is suffering from variability from a tier 1. And the tier 1 company is suffering from variability from the OEM. So the point is, we had to stop thinking in terms of isolated local operations, and we have to think that we are part of a huge global supply network. Okay, this is from the Toyota presentation. On the left, you can see the challenges they are facing. This is October this year. They have underestimated the challenges with shifting shifting to data-driven decisions. They don't have the skills and capabilities. Even though they spend lots of money on training, here we have minimal investment in education. Toyota is finding that to move into Industry 4.0, they don't have the people with the correct mindset and knowledge. Now, here you have how and where Industry 4.0 fits. And let me just focus here, right here. They are incorporating Industry 4.0 improvements into the Toyota way and Toyota production system that they have. In other words, it's very difficult and very dangerous to introduce Industry 4.0 if you don't have a robust and mature production system. I have one of the attendees asked a question. If we don't have TPS and if we don't have 5S, can we move on into Industry 4.0? The question is, based on what Toyota is saying, is that's very risky. Okay, this is the last slide from this presentation. What they're trying to achieve are robust, flexible factories of the future in order to reduce the time to do PCA. This is the final objective of Toyota. Use technology to empower its people to be able to do PDCA in a shorter cycles. Here you have this chart right here. The ERP is the spinal cord, which connects the advanced analytics, which is the external ring, with the internal operations. But the ERP is the medium to connect the external with internal. And take a look at the center. They want to do PDCA faster.
I think that's a great vision on Toyota. And I used to work at Toyota 15 years ago, and I agree with everything you say. And I'm hoping they evolved, actually. Javier, how can Industry 4.0, final question, help manufacturers during COVID-19? I think it's a critical question, actually, and it's the final question of the webinar today. What are your thoughts?
Okay, we need to take on mind always transition from the production efficiency, and we need to make a transition from production for efficiency to production for resilience. We need to think on resilience, not on production. Not in these days on the COVID area, we must need to focus on resilience for our industry. So the old systems have enough flexibility to respond to disruptions. Resilient organizations were better to able to respond. Correct path quickly with change. To build more resilient organizations, we need to design rules and structures around outcomes to increase agility and flexibility to formalize how the Industry 4.0 processes can be flexible. And employing such measures can be flexible way to promote physical health and improve our emotional well-being of our employees through technology that allow us to create a culture of inclusiveness. So thank you, Dr. Mo.
Closing statement, Dr. Vieira. One advice for manufacturers to implement 4.0.
As you said, Mo, the technology is here and has been here for 20, 30 years. Technology is not new. What we have to do is think in a systemic way and remember that we are dealing with global complex supply networks. And as Henry Ford did, let's focus on the weakest element, improve it, and that will improve the output of the whole network. Thank you.
It's a great concluding statement. And I really want to thank again and again Dr. Vieira, Mr. Javier Acosta, Mr. Eric Palencia. Please connect with them. Please add them on LinkedIn. Please send them emails. Please check their websites. Anyone else has any final thoughts before we close?
Me, Dr. Mo. So I think so that is very important to us. Focus in our talent, focus in our people, digitalize all to be related with the health of our people. We need to stop to think on product and to design. We need to be focused on resilient organizations because this problem with the COVID is not just for these years and for the next years. We need to deal with this for maybe 3 or more years more. So we need to be prepared with these technologies to focus on our production. And I think so we're going to deal well with all this. Thank you, Dr. Mo.
Industry 4.0 is truly about technology, process, and people. And then we will be very successful. Thank you all for your time. Thank you, Mexico Now. Thank you, Ramiro, Javier, and Eric. And we will talk soon in a future webinar. Have a great day. Bye-bye.
Thank you very much.
Thank you.